Okay, so we've all gotten pretty good at prompting AI, right? But what happens when one simple instruction just isn't going to cut it? This is where we move beyond just talking to an AI and get into the world of actually engineering its behavior. This is how we build something way more powerful, a true AI agent.
You know the feeling? You ask a chatbot, hey, can you draft a quick email for me? And boom, it nails it on the first try. It's fast, it's efficient, and it feels like magic, honestly. This is that simple win that got all of us hooked on this tech in the first place.
But then you get a little more ambitious. You try to give it a task with a few moving parts, something that requires a bit more, well, thought. You want it to look at data, then write a report on that data, and then take an action and email it. And this is usually where the magic starts to fizzle out. So that's the big question, right? Why does an AI that seems so smart with one thing just completely fall on its face when you ask it to do a few things in a row? It's a super common frustration, and the answer, well, the answer is the key to unlocking the next generation of AI. Well, it all comes down to the difference between these two approaches. Simple prompting is reactive. You give it an order, it gives you a result. It's great for those one-off tasks. But what we really need for complex jobs is agentic engineering, building a proactive system, an agent that's designed from the ground up for these multi-step workflows where a simple prompt just breaks. All right, so the first hurdle we have to clear is making the AI actually think logically, because you have to remember, at their core, large language models are just incredible word predictors. They're not really reasoning like we do. We have to teach them how. And this example, it just lays the problem bare. You ask an LLM a simple math problem, and it often just guesses a number that feels right. It sees the numbers 5, 2, and 3, and its pattern-matching brain just spits out 10, completely missing the simple multiplication and addition required to get the correct answer. So how do we fix this? Well, there's this really clever technique called chain of thought prompting. The idea is, instead of just asking for the final answer, you force the model to show its work. You're literally telling it to think step by step, just like you would to reason its way to a conclusion. And just look at what happens when we do that. By adding a simple phrase like, let's think step by step, we completely change the outcome. The model is forced to lay out its logic. It figures out there are 6 new balls first, then it adds them to the original 5. It's the same AI, but a much smarter prompt guides it to the correct answer, 11. Okay, awesome. So now our agent can reason. That's a huge win. But there's another problem. It's still stuck inside a box. It's limited to the information it was trained on, which is already old news. To be really useful, it needs a way to connect with the world right now. You see, the thing about chain of thought is it's all happening inside the AI's head. It's an internal monologue. And while that's great for reasoning, it can't check if its facts are right or get any new info. And that's where you get these infamous hallucinations, where the AI just confidently makes stuff up. The answer to this problem is a framework called REACT. And that stands for reason and act. This is a game changer because it gives our AI agent a toolbox. It's like giving it hands and eyes to interact with the digital world. It's not just a brain in a jar anymore. It can perform a web search, query a database, or use an API. So REACT works in this really elegant loop. It all starts with a thought. The agent looks at the problem and realizes it has a knowledge gap. It basically says to itself, I'm missing a piece of the puzzle here. I need to find out what our competitors are up to. And then, based on that thought, it takes an action. And this is the cool part. It doesn't just think, I should search. It generates a specific machine-readable command for one of its tools, telling a search engine exactly what query to run. And the last step in the loop is observation. The tool goes out, does the search, and brings back the results. This new information gets fed right back into the agent's brain, which kicks off the next thought. And the cycle just repeats itself over and over until the job is done. Okay, so let's do a super quick rundown to make sure this all clicks. If you need a simple question answered, basic prompting is your friend. If you need the AI to solve a complex logic problem internally, you use chain of thought. And if you need it to actually go out into the world, use tools, and find new info, that is a job for React. All right, this is great. Our agent can think, it can act. But if you're a developer trying to build an application with this, you're about to hit a massive wall. The AI's natural output is conversational and unpredictable, which for software is an absolute nightmare. I mean, look at this. The AI might give you something like this. It's helpful and friendly, sure, but imagine trying to write code that can reliably pull out the tool name and the input from that sentence. It's a disaster waiting to happen. The AI changes one word and your whole app could break.
And that is why you have to force the AI to speak the language of computers, structured JSON. I mean, just look at the difference. This isn't a suggestion anymore, it's a command. It's clean, it's predictable, and most importantly, it's machine readable. It becomes a reliable API response.
Now, getting the AI to give you this perfect JSON every single time isn't luck. It's a science, and there are rules to the game. First, you gotta be explicit. Tell it you want JSON. Second, give it the exact blueprint, the schema. Third, show it what a perfect example looks like. And finally, use strong language. Tell it only JSON, no extra chat.
Okay, so we've got the building blocks, right? We have logical reasoning with chain of thought, real-world actions with React, and reliable outputs with JSON. So now, let's put it all together and see what this looks like in a real-world application.
A fantastic example of this is a fully automated SEO agent. Think about everything that goes into that. It has to research competitors, plan an article, write the thing, and then actually publish it to a website. That's way too much for a simple prompt, but it is the perfect job for an agent.
So here's how that agent would actually work using everything we've talked about. First up, it uses React to go out and scrape the top search results to spy on the competition. Then it uses chain of thought for the brain work, planning the perfect structure for a new article. And finally, it formats its output as clean JSON to reliably call the website's API and get that article published.
All right, so let's wrap this up with the key takeaways. Agentic workflows, this is the future of automation. Chain of thought is for the brain work, the internal planning. React is what gives the agent hands to act in the real world. And structured JSON, that's the secret sauce that makes the whole system reliable enough to actually use. So look how far we've come. We've moved from just asking simple questions to actually engineering these complex autonomous systems. The tools are here, they're incredibly powerful, and they're ready to go. The only question left is, what problems are you going to solve with them?